Assalamualaikum. Hi, my name is Muhammad Umar QAIYUM bin OTHMAN. Now I will present my project that called BIM Sign Language Recognition System for Subject Artificial Intelligence. Okay, first is problem statement. BIM or Bahasa Isyarat Malaysia is the primary sign language of Malaysia's deaf community, yet it remains largest unknown to the general public. This creates a communication gap that leads to social exclusion in education, employment, and daily life. Okay, objective for this project is first, train a ML model on teachable machine to recognize BIM gesture A to G. Second is, evaluate model accuracy across all 10 gesture classes. Third, deploy the model as a real-time web app using TensorFlow.js. And fourth, lastly, is promote communication accessibility for hearing impaired patients.
Hello, Assalamualaikum. My name is Mohd Feisal Arif Mohd Fauzi. So today I will be continuing the next slide, which is solution design and architecture. So the system follows a 3-layer pipeline. First, the input layer. The user webcam continuously capture live video frames. These frames are then passed to the processing layer, where TensorFlow.js runs our trained mobile net CNN model directly inside the browser. So it classifies each frame into one of the 10 beam gesture class. So finally, at the output layer, the predicted beam data is displayed on screen in real time, along with the confidence score. So the key thing here is that everything runs in the browser, no server, no installation, just open the web app and it works. So on to the next slide, which is model development using teachable machine. So for model development, we use Google Teachable Machine, which is a no-code machine learning platform. So the model works in 4 steps. First, transfer learning. We use MobileNet, which is pre-trained on millions of images from ImageNet. So this gives our model a head start. Then feature extraction. The CNN identifies important visual features like hand shape and finger positioning. Next, fine-tuning. The model adapts specifically to our beam gesture dataset. And finally, classification. So the model outputs which of the 10 gesture classes best match what the webcam sees. So for training, we collected over 300 images per class, trained for 50 epochs with a batch size of 16 and learning rate of 0.001. So everything was done on the teachable machine platform itself. So thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we will show the demonstration of our machine, and I will show 2 or 3 example the letter that our machine can learn. For example, if we show this, the machine will trace as a A. Second, if we will show this, the system will trace as a B. Yeah. Because of the camera is not so clear, so the system is black. But the system still can trace the B. Second, B. So we will show also for F. Then we can show also I, as you can see. So this is some demonstration video that our machine can learn the sign language. Thank you.
My name is Muhammad AMINUDDin bin SAIFON. My metric number is B03241192, and today I would like to continue the presentation. Okay, after training our model using teachable machine, we tested it on all 10 sign language classes, which are the letters A until J. As shown in the graph, the model achieved on an overall average accuracy of 65.7%. The best performing class was letter I, which reached 100% accuracy. This means the model was able to recognize that gesture correctly every time during testing. On the other hand, letter J had the lowest accuracy at 39%. This is likely because the gesture of J involves making movement, making it more difficult for the model to distinguish compared to static hand signs. Overall, 3 out of the 10 classes achieve an accuracy of 80% or higher. Although the model is not perfect yet, these results show that it can recognize several BIM gestures effectively and provide real-time predictions. So, based on these results, we can conclude our project that, in conclusion, our project successfully developed and deployed a BIM sign language recognition system using Teachable Machine and TensorFlow.js. The system demonstrates that artificial intelligence can be used to improve communication accessibility for Malaysia's hearing impaired community by recognizing BIM hand gestures in real time. However, there are still several improvements that can be made in the future. Firstly, we can expand the system to recognize the complete BIM alphabet from A to Z as well as common words. Second, we can improve models' accuracy by collecting more diverse training images from different users like lighting condition and backgrounds. Third, we can integrate a text-to-speech feature so that the recognized signs can be converted into spoken words. Finally, the system can be deployed in schools or for the deaf people, public facilities to support better communication between deaf individuals and the general public. Thank you.